Students, today we are going to discuss SRO number 15.3.1, which is related to isomerism, structural and stereoisomers. These are two types of isomerism. So first of all, we would understand like what is isomerism itself. Then I will tell you इसकी दो types कौन-कौन सी हैं, stereoisomers and structural isomers. जब भी आप आइसोमर वर्ड सुनते हैं तो आपके पास दो कीवर्ड्स जो हैं वो इसको डिफाइन करने के लिए इनफ है. द फर्स्ट वन इज सेम मॉलिक्यूलर फॉर्मूला and the second key is different chemical structures. What does it mean? For example, we have C4H10, right? In C4H10 there are 4 carbon and 10 hydrogen. If we draw the skeleton formula, there are two possibilities: CH3, CH2, CH2 and CH3. That is the linear chain in which 1, 2, 3, 4 carbons are there, C4, and 3 plus 2, 5, 5 plus 2, 7, 7 plus 3, 10. So hydrogen, how many hydrogen are present over there? There are 10 hydrogen present. If we look for another possible skeleton of this C4H10 molecular formula, so it can be 3 carbons linearly arranged, CH3, CH2, CH3, and there would be CH3, CH, and CH3. So if we form another isomer, so another carbon would be there in branch. So we would have this skeleton: 1 carbon with 3 hydrogen and 1 bond. Valency of this carbon is fulfilled. Central carbon is bonded with 3 carbons, so 1 hydrogen with it, and the last 2 carbon are also terminal carbons, so one bond with carbon and 3 bond with other hydrogen. Let us count the number of carbon: 1, 2, and 3, and the branch 1 is 4, C4. 3 hydrogen here, 3 plus 1, 4, 4 plus 3, 7, 7 plus 3, 10, H10. So both have same molecular formula. The molecular formula over here is C4H10 in both. But the skeletal formula or the molecular structure is different. There is a linear structure, that's why called N-butane. And this one is a branch structure in which 3 carbon are linearly arranged and 1 is in branch. So it is also known as isobutane. Butane means 4 carbon skeleton, but both are different in physical structures because they are isomers of each other. So isomerism is simply when the same molecular formula have different chemical structure. They can be 2 or more than 2 depending upon the type of compound we are taking. So that would be isomerism. Now, there are different types of isomerism we would understand to understand the stereo and structural isomerism. The isomers are divided into 2 categories on the basis of connectivity. The first one is when connectivity is same. Connectivity is same. What does it mean? Like we have C2, H2, Cl2. In C2, H2, Cl2, there is a possibility that there are 2 carbon directly bonded with each other, 2 chlorine, each carbon is having 1 chlorine, and 2 hydrogen, each carbon is having 1 hydrogen. So that is the possible structure A. If we want to form another possible structure of this compound, that can be carbon directly bonded with carbon, 1 chlorine, another chlorine, 1 carbon with hydrogen, another carbon with hydrogen. Can you find out what is the difference in A and B? As I told you, the connectivity is same. Same connectivity means what? If we look like for first carbon is directly bonded with 1 chlorine, 1 hydrogen, and 1 carbon. Similarly, in this, first carbon is bonded with one chlorine, one hydrogen, and one carbon. But this carbon is having chlorine, that is heavy atom, bulky group upside, and second carbon is having chlorine, that is bulky group downside. That means both carbon are having chlorine that are bulky group in opposite direction. But when we look towards another skeleton in which we have two chlorines, so the position of chlorines in this is on same. So both structure are same, their molecular formula is same, molecular formula would be same, their connectivity is same, connectivity to the atom, like central carbon is directly connected to hydrogen and chlorine and carbon. Similarly, this carbon is connected to hydrogen, chlorine and carbon. In this skeleton, same connectivity is there. First carbon is connected to hydrogen, chlorine and carbon. Second carbon is also connected to hydrogen, chlorine and carbon. But what is the different orientation? Orientation of heavy atoms is different. In this, the heavy atom we can say are in opposite direction. This chlorine and this chlorine are in opposite direction, while in that skeleton, the chlorines, the heavy atoms are on same direction. So that type of isomerism is known as stereoisomerism. The keyword for stereoisomerism is same connectivity but different orientation, different orientation of atom in space. Same connectivity but different orientation of atoms in space is known as stereoisomerism. Now, what is structural isomerism? As I told you, if the connectivity would be same, these are stereo. But if the connectivity would be different, they are known as constitutional isomers. Constitutional isomer. Now, what does it mean? Constitutional isomers has different type of connectivity. There are different type of constitutional isomers, out of which we have discussed just one, that is positional isomers, or we can say structural isomer like linear chain and branch chain. So this type of isomerism in which the connectivity of carbon atom is different. So these type of isomerisms are known as constitutional isomer. There are different type of constitutional isomers. Let us discuss one by one all these types. The first type of constitutional isomer is chain isomerism. What is chain isomerism? It is a type of isomerism in which we have same molecular formula but different physical structures of these formulas. For example, we discuss butane. Let us discuss another example, C5H12. Now for C5H12, if we look, there are 5 carbon, 1, 2, 3, 4 and 5. These 5 carbon can be linearly arranged, that is N-pentane, 1, 2, 3, 4. 4 carbon are in chain and 1 is in branch. So that is also C5H12, that is also known as isopentane. And if we arrange 3 carbon linearly, 1, 2, 3, and fix 2 methyl group or 2 carbon in same position in a branch, that is known as neoskeleton. So in all these, how many carbons are there? 5 carbon. Let us count carbon number 1, 2, 3, 4, 5. In this, carbon number 1, 2, 3, 4 and fifth one is in branch. In third structure, carbon number 1, 2 and 3. The remaining 2 are in branch. That is one is 4 and that one is 5. So all these 3 structures are chain isomers of each other. The key identification of isomerism that I told you, was the example of chain isomers. The chain isomers are the isomers which have same chemical formula but different physical structure, and the phenomenon is known as chain isomerism. The second example we are going to discuss is of position isomers. The position isomers would have the same type of chain. For example, if we have C5H11OH, that is an alcohol. In this alcohol, if we arrange 5 carbon linearly, 1, 2, 3, 4, and 5. These 5 carbon are arranged linearly. If I'm going to arrange OH on second position, so that is structure A. Another form I'm going to form from this is 1, 2, 3, 4, 5 carbon linearly arranged. And this time I'm going to attach OH group on third position. That is skeleton number B. Now, what is the difference between A and B? In A, the heteroatom is attached on position 2, while in skeleton B, the heteroatom is attached on carbon number 3, 1, 2, and 3. So, if the position of bulky group or the heteroatom is different, but the main chain is same, this type of isomerism is known as position isomerism. If we take another example of position isomer, that could be C4H7, H9, Br. Okay. The general formula which we are going to use is CnH2n plus 2. So 8 into 2, 4 into 2, 8, 8 plus 1, 9, and another one is replaced by Br. So 4 carbon are there, 1, 2, 3, 4. If I arrange Br on first position, what could be another chain isomer for this? The position of Br would be changed. 1, 2, 3, 4. 4 carbons are there. Now we can arrange Br at any of the position. We can arrange it on second position. So it could be the chain position isomer of this. What is the position isomerism? The position isomerism means the main skeleton is same, but the position of heteroatom attached to that skeleton is different. Up till now, we have discussed two types of isomerism. The first one is chain isomerism, in which molecular formula is same, but their physical skeletons were different. In second type, position isomerism, the molecular formula is same, basic skeleton is also same, but the position of heteroatom attached is different. The third type of isomerism that I'm going to discuss here is functional isomerism. Now, what is functional isomerism and what are functional isomers? The functional isomers would have same molecular formula but different functional group. If we have C2H6O, okay, that is the molecular formula. Out of which, if I want to draw the skeletal formula, that could be CH3, CH2OH, the first possibility, and the second possibility, CH3O, CH3. If you recall the identification of functional group, I told you to identify the functional group, first of all, find out heteroatom. The heteroatom is there and it is attached to R group. That one is ROH. And the second one, the heteroatom is central and it is directly connected to 2R group. That is R, O, and R. Which one is the functional group of this skeleton? ROH, it is alcohol. What about this one? This one is ether. Are these two functional groups same? No. Molecular formula is same, that is C2H6O, but the first skeleton is the representation of alcohol and the second skeleton is the representation of ether. When that type of two skeleton are present with the same molecular formula, these type of isomers are known as functional isomers. In functional isomers, what we have, same molecular formula but different functional group. Obviously, if the functional group are different, so the main skeleton can also be different. Okay,